Welcome back, everybody. We're up to lesson 2 of Unit 6. No new lesson notes in this lesson. All the notes for the first half of Unit 6 were given to you in the Unit 6 Lesson 1 slides, so you should have those notes copied down already. So let's go right into the examples here. Okay, so here we have a triangle. What are cosine D, sine D, and tangent D? Explain how you know. First thing we're going to do is we're going to figure out the lengths of the sides of this triangle. So to figure out this side right here, okay, all I need to do is count. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this side has a length of 12. Okay. This side has a length of 1, 2, 3, 4, 5. Now I just need to figure out the length of the hypotenuse. So to do that, just like with the previous lesson, I'm going to use the Pythagorean Theorem. So this is going to be 12 squared plus 5 squared equals c squared. Remember, c is the hypotenuse, so that is going to have to be the unknown value in this case. So this will be 144 plus 25 equals c squared. So this gives me c squared equals 169. Okay. So when I take the square root, it's going to be c equals 13. So the length of the hypotenuse is 13. Now that I know the lengths of the sides of the triangles, if I go back to the lesson notes, I can now use SOHCAHTOA to figure out sine, cosine, and tangents. Okay? So sine of D, so D is right here. That's going to be so opposite over hypotenuse. Opposite over hypotenuse is going to be 5 over 13. Okay. Cosine of D, that's going to be adjacent over hypotenuse. So in this case, that will be 12 over the hypotenuse, which is 13. Okay. And then tangent of D is opposite over adjacent. So opposite we said is 5, and adjacent we said was 12. So tangent is 5 over 12. So sine, cosine, and tangent of D are these three things right here. Okay. Number 2. Okay. Here is a triangle D here's a triangle similar to triangle DEF. What is the scale factor from DEF to D prime, E prime, F prime? Okay. So to do that, let's again figure out the side lengths of the triangle. So my horizontal side here is going to have a side length of, looks like 36. Okay. This is going to have a side length of 15. So again, I'm going to use the Pythagorean Theorem. So to figure out the Pythagorean Theorem, to figure out the hypotenuse, I'll do that up here. So a squared plus b squared equals c squared. So this will be 15 squared plus 36 squared equals c squared. This one I'm going to use a calculator for. So 15 squared is 225. 36 squared is 1,296. So we end up with c squared equals 1,296 plus 225. So that's 1,521. Okay. And now I need to take the square root of that. So I get, if I square root both sides, I get c equals 39. Okay. So by asking for the scale factor, they're asking what am I multiplying all of the sides of the first triangle by to get to this triangle? Well, here 5 times what is 15? Looks like it's going to be 5 times 3. Is 12 times 3 equal to 36? Yes. Is 13 times 3 equal to 39? Yes. So what is the scale factor? The scale factor is 3. And then to figure out cosine of d prime, okay, cosine of d prime, that's going to be this one right here. So that's going to be adjacent over hypotenuse. In this case, that will be 36 over 39. Okay. Sine of d prime. Okay, that's going to be opposite over hypotenuse. That's going to be 15 over 39. And then tangent of d prime, that's going to be opposite over adjacent. So that will be 15 over 36. Okay, so there's your cosine, sine, and tangent of d prime this time. So that's it for number 2. Number 3, here's another triangle similar to triangle DEF. So we have D double prime, E double prime, and F double prime. Okay, so there's A. What is the scale factor from DEF to D double prime, E double prime, F double prime? So let's figure this out here. So I know that the radius in this case is 1, or excuse me, the hypotenuse is 1. It looks like the horizontal side is also going to be 1 because this is a half and this is 1. Okay. And actually, I'm incorrect. Okay. So let's go back and look at this here. I know that the radius, I know that the hypotenuse is 1. Okay. So to go from 13 to 1, that means I have to divide by 13. Well, dividing by 13 is the same as multiplying by 1/13. So what is the scale factor from DEF to D double prime, E double prime, F double prime? The scale factor is 1/13. Okay? The scale factor is 1/13, which means to figure out the other two sides. So, for example, the horizontal side of the original triangle was 12. I'm going to take 1/13 and I'm going to multiply it by 12. Okay, 1/13 multiplied by 12. Let's get a decimal value here. Okay. Decimal value, this is going to be approximately 0.92. And to figure out the other side, I have to take 1/13 times 5. So 1/13, I'm just using a calculator, times 5 is approximately 0.38. So this side is 0.38. Okay. So the scale factor is 1/13. What are the coordinates of f double prime? So that's this point right here. So my x value is 0.92 and my y value is 0.38. So the coordinates of f double prime is going to be 0.92 comma 0.38. Okay, so there's your answer to C. And what are cosine of d double prime, sine of d double prime, and tangent of d double prime? I'm going to do the same thing I did in the first two examples. So cosine is adjacent over hypotenuse, so that's going to be 0.92 over 1, which is 0.92. Okay. Sine of d double prime is going to be opposite over hypotenuse, so that will be 0.38 over 1, which is 0.38. And tangent of d double prime is going to be opposite over adjacent, so that will be 0.38 divided by 0.92. Okay, so 0.38 divided by 0.92, and I'll just leave it as that. Okay, so those are your cosine, sine, and tangent values. So that is it for my examples, and that is it for lesson 2.